Okay, so let us go over some common terms found in geometry, and I'll start with points. A point of paper is represented by a dot, but ideally a point is just a location in space. That is, these points have no thickness, no length, no height, no width, no depth. They have no dimension. They're just locations. A line is, think of it as a straight line that goes on forever in two directions. And it can be said that whenever you have 2 points, there is one unique line that goes through them. So any 2 points determines a line. Likewise, any 3 points determines what's called a plane, which is, think of it as like a sheet of paper that goes on forever in all directions. Going back to lines, if you happen to have 3 lines that or more lines that all intersect at the same point, we call them concurrent. So if there happens to be a point that is in each of the lines, in this case I, J, and K, those lines are said to be concurrent. Now, on the other hand, if you happen to have 3 lines and 2 of them are parallel or at least not intersecting in that place, and there's a third line that's intersecting both of them. So in this case, there's R and S that are parallel to each other, and there's a third line T that's going through each of those at different places. That T is called a transversal. So a transversal is a line that's intersecting 2 other lines. So when we have 2 lines, there are, in terms of the possible arrangements, is that those lines, we're talking about possible arrangements of 2 lines that are on a plane. Those lines could be parallel, or they could intersect at a point. So on a plane, 2 lines are going to be parallel, never touching, or they'll be touching at one place. With 3 lines, there's a few more possibilities, one of which is that all 3 lines are parallel to each other. Another possibility is that those 3 lines all intersect at the same place and are called concurrent. It could be that 2 lines are parallel and a third line is intersecting those 2. Or it could just be they all have different slopes and they're intersecting at different places. So the 3 lines are in what we call a general position. Now, if you just want to take a small finite segment of a line, something that has a start and stop point, we call that a line segment. So a line segment is just some finite piece of a line. As far as notation goes, if it's a line, then we have a line is drawn with the names of the points, 2 points with a line on top of it with arrows going in both directions. A line segment doesn't have the arrows, it's just a AB with a bar. And if I don't have any bar, then I'm actually just talking about the length of it. So in this case, AB would be the length between points A and points B. Okay. So what we have here is, if I have AB with a bar over it, that's the segment AB. If I'm just saying AB, that's the length. If I have 2 different segments and there's little tick marks in them, that means that they're congruent and that they're the same length. And the last one there, if you notice, I have an M that's in between them, and then the left and right side of it are congruent. That M would be the midpoint. All right, so a ray is essentially a line with a starting point and then going on forever in one direction. So a ray is a subset of a line that contains a point, we call it the endpoint of array, called the endpoint array, and all points of the line that's lying to one side. So you have a starting point and then you're going on forever in one direction. That would be a ray. Angles are unions of 2 rays with a common endpoint. So an angle whose sides are not the same, not on the same line partitions of the remaining points of the line in 2 points. Let's try this again. And angles whose sides are not on the same line partitions the remaining points of the plane into 2 parts. So there's the interior of the part, which is the smaller part of the angle, and the exterior is the larger part. An angle whose sides are not in the same line partitions the remaining points of the line into two parts. I guess I already said that. So some common errors. A zero angle is one where both rays are identical to each other, so there's nothing in between them. They're both pointing in the same direction. An acute angle is one that the angle is between 0 and 90 degrees. Right angle is one where the angle is exactly 90 degrees. Obtuse angles are between 90 and 180. A straight angle is equal to 180. And then if you get something more than 180, less than 360, that's called a reflex angle. So that's basically the larger angle to an acute angle, to acute or obtuse angle. Two angles are congruent if and only if they have the same measure. Two angles are complementary if the sum of the measures is 90 degrees. Two angles are supplementary if their sum is 180. So, for instance, an angle measures 37 degrees. The measure of the supplementary angle would be 180 minus 37, and that would be, I guess, 143 degrees. If I want the complementary angle, I would do 90 minus 37. So the complementary angle would be 53 degrees, since 90 minus 37 is 53. Okay, a couple more terms. Two angles that have a common side and non-overlapping interiors are called adjacent angles. So adjacent angles basically are just right next to each other. They're like puzzle pieces kind of put together. So angles 1 and 2 are adjacent supplementary angles. Angles 3, 4 there you see are adjacent complementary angles. Two non-adjacent angles formed by two intersecting lines are called vertical angles. So in this case, angle 1 and angle 3 are vertical angles. Angle 2 and angle 4 are vertical angles. One property of vertical angles is that they always have the same measure. So angles 1 and 3 are congruent. Angles 2 and 4 are congruent. So when two lines are crossed by another line, the angles in matching corners are called corresponding angles. So in this case here, angle 1 and angle 5 are corresponding. Angle 4 and angle 8 are corresponding. Angle 2 and angle 6 are corresponding. And angle 3 and angle 7 are corresponding. If you happen to have two parallel lines cut by transversal, then the corresponding angles will always have the same measure. That is, angle 1 is going to be congruent to angle 5, angle 2 is congruent to angle 6, angle 3 is congruent to angle 7, angle 4 is congruent to angle 8. So putting these all together, let's say I know that angle 6 is 35 degrees. I want to find the measure of the remaining angles. Well, if angle 6 is 35, angle 8 would be 35 degrees because vertical angles have the same measure. Well, angle 6 corresponds to angle 2, so angle 2 would have 35 degrees. And likewise, angle 4 would be 35 degrees as well. Now, as for the other ones, notice that angles 1 and 4, so angles 1 here and 1 and 4 are supplementary. So I can find angle 1 by doing 180 minus 35, which is 145. So angle 1 would be 145 degrees. And then likewise, by vertical angles, angle 3 is 145 degrees. And then 5 and 7 are corresponding angles. So now we have the angles of all the parts.